Intel is best known for central processors, but a modern Intel PC can contain several kinds of graphics. Some processors include integrated graphics for displays, media, and lighter workloads. Intel Arc is the dedicated graphics family designed for gaming, creation, and parallel compute. The CPU and GPU share a company name, but they solve different problems. Modern Intel desktop and laptop processors can use a hybrid core design. Performance cores target demanding, latency-sensitive work. Efficient cores handle scalable or background work within a different power and area budget. The operating system and Intel's hardware guidance help schedule threads. This does not mean every application automatically becomes faster. Software behavior, core counts, clock speeds, cache, power limits, and cooling still decide the outcome. Intel processor names change across generations, so compare the exact model rather than relying on core branding alone. Check physical cores, threads, cache, integrated graphics, supported memory, power behavior, socket, and motherboard firmware. Laptop performance is especially dependent on the manufacturer's cooling and power configuration. Two machines using a similarly named processor can sustain different speeds. Intel Arc dedicated GPUs organize graphics work into XeSS cores. Product specifications can also list ray tracing units, XMXAI engines, memory capacity, and bandwidth. XeSS cores, AMD compute units, and NVIDIA CUDA cores are different architectural measurements. Never compare their raw counts directly as if they were the same unit. Arc ray tracing units accelerate portions of ray workloads. XMX engines accelerate matrix operations used by technologies such as XeSS image reconstruction and other AI compute. XeSS can render at a lower internal resolution and reconstruct the final image in supported games. As with every upscaler, judge image stability, motion, detail, latency, and the performance of the original rendered frames. Media is an important Intel strength to evaluate. QuickSync Video has long used dedicated media hardware in supported Intel graphics. Arc products can accelerate modern encode and decode workflows, including AV1 on supported hardware and software. For streaming or editing, verify that the exact application supports the codec and acceleration path you plan to use. Early Arc generations also made platform configuration especially important. Features such as resizable bar can materially affect supported Arc performance, so check Intel's current requirements, motherboard support, firmware settings, and driver guidance for the exact card. Keep graphics drivers current through Intel's official channel, but document changes and avoid updating during critical work without a rollback plan. Intel can be a useful choice when the price, media engine, application support, display features, or game performance fits the build. It can also be the wrong choice when a required game, professional tool, or older platform has compatibility limitations. That is why workload testing matters more than novelty. Compare core CPUs with competing processors in the exact games and applications you use. Compare Arc GPUs with Radeon and GeForce at the same resolution, quality settings, power class, and price. Check memory, cooling, case fit, power supply, drivers, and warranty. Intel CPU and GPU products add competition and useful technology to the PC market. Your job is not to reward a company for entering a category. Your job is to choose the processor and graphics solution that produce stable, supported performance for your actual computer.